So welcome back to another video lesson. Today we shall discuss what are ions and we shall understand how to write down the chemical formula of some compounds. So let's begin with the first topic for today. What are ions? So far we have discussed about atoms and molecules. The atoms are represented by symbols. Molecules are also shown by certain symbols, but these are known as formula. Now, how to write down the formula for certain compounds, that we will be learning a bit later, but one thing has to be understood, that these molecules are neutral in nature. This means that they do not have any charge, but in some compounds such as say calcium oxide, certain charge species are present. These are known as ions. So how to define ions? An ion can be defined as an atom or group of atoms having positive or negative charge. The ion which has one or more positive charges is called cation. At the same time, the ion carrying one or more negative charges are known as anion. Formation of ions is something that we will be discussing while we are studying the next lesson. But right now, I will give you some examples of cations. So positively charged ions or cations, like for example Na plus, which is the sodium ion, K plus, which is the potassium ion, Ca2 plus, which is the calcium ion, and Al3 plus, which is the aluminium ion. Similarly, few negatively charged ions such as chloride ion, sulfide ion, oxide ion. Now, ions formed from group of atoms and carrying either positive or negative charges are known as polyatomic ions. So, I will also give you some examples of what are called the polyatomic ions. So, PO4 3 minus, this is the phosphate ion. Similarly, SO4 2 minus, this is the sulfate ion. Similarly, I'm just writing it on the top, NO3 minus, this is the nitrate ion. NH4 plus, and this is the ammonium ion. So there are many such polyatomic ions. Now we shall understand the chemical formula of compounds. We know that atoms of elements combine to form a molecule. We represent the atoms with the help of symbols. In the same way, the molecules can also be represented by the symbols of the constituent atoms. So, chemical formula may be defined as the shorthand representation of the name of a molecule in terms of the symbols of the constituting atoms. Like for example, formula for water is H2O, formula for ammonia is NH3, formula for sodium chloride is NaCl. Let me just write it properly, NaCl. And formula for sulfuric acid is H2SO4. Now we have seen that in the molecules the atoms are combined with each other. Different elements have different combining capacity of their atoms. This is known as valency. So what is valency? The combining capacity of an element. So how it is expressed? It is expressed in terms of the number of hydrogen atoms, number of chlorine atoms, or double the number of oxygen atoms which combine with one atom of that element. Now for example, in NH3, valency of nitrogen is 3. Similarly, if we consider the example of say methane, which is CH4, valency of carbon is 4. In CO2, valency of carbon is 2. In water, valency of oxygen is 2. In addition to the atoms, the ions which are charged species have also some valencies. Positive ions or cations have positive valencies, negative ions or anions have negative valencies. The valencies of the polyvalent ions are expressed by enclosing them in bracket and putting the positive or negative signs outside it. So let me show you the valency of positive ions or cations. Now positive ions may be monovalent, bivalent, trivalent, tetravalent, depending upon the charge present on them. Like as you can see in the picture right now, hydrogen, potassium, sodium, silver, copper, gold, ammonium, these are all monovalent ions. Similarly, barium, calcium, magnesium, zinc, cobalt, copper and iron are bivalent, while aluminium, chromium, iron and gold are trivalent. The same rule can be applied for the negative ions or anions. So like positive ions, negative ions may also be monovalent, bivalent, trivalent, tetravalent and so on in nature. Like going by the present chart, that is coming right now on your screen. Chloride, bromide, iodide, hydroxide, nitrate, nitrite, hydrogen carbonate, cyanide, permanganate, chlorate, these are all monovalent. Sulfide, oxide, carbonate, sulfate, sulfite, manganate, oxalate, chromate and dichromate are bivalent, while nitride, phosphide, phosphate, borate and arsenate are trivalent. So using the knowledge of valency, now we shall begin writing chemical formula. So let's begin by writing chemical formula of simple molecular compounds. In the formation of simple molecules, atoms of the elements participate. The symbols of these atoms are written and their valencies are placed below them. These valencies are shifted crosswise to the lower right of these atoms. Like for example, I will do it for the formula of ammonia. So ammonia has got nitrogen and hydrogen. So as it was said that the symbols of these atoms are written and their valencies are placed below them. So valency of nitrogen is 3 and that for hydrogen is 1. So now what shall we do? We will shift crosswise these valencies. This is known as the crossover or crisscross of valencies. So in order to write down the formula, we shall crisscross the valencies. So 3 will go this side and 1 will go this side. So hence we can write down the formula of ammonia as NH3. Let's do it once more. We will try the same rule for methane. Methane has got carbon and hydrogen. Writing down the valencies below. Carbon's valency is 4 and hydrogen's is 1. Now let's do the crisscross part. So 1 goes this side and 4 goes to the other side, and hence the formula of methane becomes CH4. Now writing down once again for another compound, carbon dioxide. Carbon dioxide has got carbon and oxygen. Valency of carbon is 4, valency of oxygen is 2. Now we have to do the crossover. So 2 will go this side and 4 will go to the other side. So hence the formula of carbon dioxide should become C2O4. But in case there is some common factor, it has to be taken out. So this is not C2O4, rather it should be written CO2. In the formula of the compound, the valency 1 is normally omitted. So as you can see in the first case and the second case, it is written NH3 and C4 instead of writing N1H3 and C1H4. The molecular compounds are also called covalent compounds. The compounds listed above are heteroatomic in nature. It means that different elements participate in these compounds. They may be homoatomic also, which means that these are formed from the atoms of the same element. For example, hydrogen molecule, which is H2, chlorine molecule, which is Cl2, oxygen molecule, which is O2, nitrogen molecule, which is N2, and so on. Now let's proceed with the next category. Now we will write chemical formula of simple ionic compounds. Simple ionic compounds are of binary nature. It means that both the positive and negative ions have one atom only. The symbols of these ions are written side by side with their valencies at their bottom. A common factor, if any, is removed to get a simple ratio of the valencies of the combining atoms. The criss-cross method is then applied to arrive at the final chemical formula of the compound. So let's begin with a simple ionic compound, that is, let me just write it properly. So we will begin with the simple ionic compound, that is sodium chloride. So first of all, we will write down the symbols of the atoms participating in it. So it is sodium and chlorine. Symbols are Na and Cl respectively. Let's write down the valencies. So sodium ion has got 1 plus and chlorine is 1 minus. So now we have to do the crossover. So 1 plus goes this side and 1 minus goes this side. So now the formula becomes NaCl. Let's do for the next one. Potassium bromide, K and Br. Potassium is 1 plus and Br has valency 1 minus. Now coming to the crossover, so 1 plus goes this side and 1 minus goes this side, and hence the formula becomes KBr. Let's write down one more expression. Say we are writing for zinc oxide. So zinc and oxygen. Zinc has a valency 2 plus, oxygen is 2 minus. We have to do the crossover, so 2 plus goes this side and 2 minus comes this side, and hence the formula, what should it become? Zn2O2? No, it will become ZnO, as we know that we have to get rid of the common factor. Let's write one more. We will write down the formula for aluminium oxide. So Al and O. Aluminium, the valence is 3 plus. Oxygen, it is 2 minus. We shall do the crisscross. So 2 minus comes this side and 3 plus goes this side, and hence the formula becomes Al2O3. So in this manner we can write down the formula for simple ionic compounds. Now we will try to write down the chemical formula of ionic compounds containing polyatomic ions. Now if we look at the list that I have shown you for the positive and negative ions, in that we find that mostly the negative ions or anions are polyatomic ions, isn't it? Let's go back to that particular chart. See, this was the chart for positive ions. This is the chart for the negative ions or the anions. So we find that mostly the negative ions or anions are polyatomic ions, while the positive ions or cations are simple ions. These are simple ions, but the negative ions are mostly polyatomic ions. Now an exception in this case is ammonia. See, this is a polyatomic ion carrying a positive charge. It is a polyatomic ion, and just note the manner in which it has been written. We have to enclose it inside a bracket and then put the charge. So while writing down the formula of compounds which involve polyatomic ions, we have to keep this thing in mind, that we have to always include the polyatomic ion inside a bracket. So let's discuss writing down expressions for some compounds having polyatomic ions. Let's begin with sodium phosphate. So sodium phosphate, Na and PO4. This is the phosphate ion. Sodium ion has a valency of 1 plus and phosphate ion 3 minus. So now we will do the crisscross. So 3 minus comes this side and 1 plus goes this side. So now the formula becomes Na3PO4. Now let's write down the expression for the next term, next compound, ammonium carbonate. So ammonium, it is NH4, and carbonate, it is CO3. Ammonium has got a charge 1 plus and carbonate has got 2 minus. So now we need to do the crisscross. So 2 minus comes this side and 1 plus goes that side, and hence the formula becomes NH4, putting it inside bracket 2 and then CO3. So this is the formula for ammonium carbonate. Now let's write down the formula for one more compound. It is potassium dichromate. So potassium dichromate has got potassium and the chromate ion is Cr2O7. So now writing down the charges, potassium is 1 plus, and what about dichromate? It is 2 minus, as you can see from the chart itself. Can you find out dichromate? See. So now let's do the crossover. So 2 minus will come this side and 1 plus will go that side. So hence the expression becomes K2 Cr2 O7. So this is the formula for potassium dichromate. Right now on your screen you can see the chemical formula of a few common compounds. So there is ammonia, that is NH3, carbon dioxide is CO2, sulfur dioxide SO2, sulfur trioxide SO3, sulfuric acid H2SO4, nitric acid HNO3, phosphoric acid H3PO4, sodium carbonate Na2CO3, ammonium chloride NH4Cl, calcium carbonate CaCO3, acetic acid CH3COOH, ethyl alcohol C2H5OH, ethane C2H6, and sucrose C12H22O11. In this manner, using the method of writing down the chemical formula, we can understand how, making use the concept of valency, we can very easily write down the expressions for so many different compounds. Now I would suggest that you practice writing down the formula for different compounds. First of all, you need to remember the valencies, the symbols and valencies properly, and then you would be able to write down the formula for different compounds quite easily. But you require a lot of practice. The lesson will end at this point. We shall move ahead with the remaining topics in the chapter in the next video lesson. Thank you.